Welcome. Today on The Explainer, we're going to dive deep, and I mean really deep, inside the human ovary. We're going to witness one of the most incredible developmental races in nature, the life story of a single egg cell. It all starts with this number, 1 million. See, at birth, a human ovary is just packed with about 1 million of these potential egg cells, which we call oocytes. Every single one is a tiny seed of potential, just waiting for its shot. But here's the crazy part. Out of that million, only about 500 will ever actually be released in a lifetime. So what is this incredible marathon they have to run? And what happens to all the others? Well, let's find out by following the journey of just one of these ovarian follicles. All right, first things first, let's get our bearings. To really understand the follicle's journey, we need to know the landscape, the environment where this whole drama unfolds, the ovary itself. So think of the ovary as having two main neighborhoods. You've got the outer cortex, that's the action zone. It's where every single one of the follicles lives and develops. And then you have the inner medulla, which is basically the support hub, totally packed with all the blood vessels and nerves needed to keep the whole operation running smoothly. So, the big takeaway here, the one thing to remember, is that our whole story, from the very beginning to the very end, it's all happening right there in the cortex. Yeah, the medulla is absolutely vital for support, but the cortex, that's the main stage. Okay, so now it's time to meet our main character. Just like nearly 1 million of its neighbors, our follicle starts its life in this really quiet, dormant state. Pretty much just waiting. And here it is. This is a primordial follicle. It's incredibly simple, right? It's just a primary oocyte, that's the potential egg, wrapped in a single layer of these flat little cells. And, most of these follicles will just wait. They'll spend years, sometimes even decades, in this quiet, suspended state. But then, puberty hits. And that's when hormonal signals start to wake up a small group of these follicles with each cycle. You can see the central oocyte starts to get bigger, and those flat cells surrounding it, they plump up into a cube shape. And that pink layer, that's a tough protective shell called the zona pellucida forming around it. This is now what we call a primary follicle. So the race is on, but most of the contenders are actually going to drop out pretty quickly. For the lucky few that keep going, this next phase is all about rapid growth and getting really specialized. As our follicle matures into a secondary follicle, things get really dramatic. A fluid-filled space, that little pocket you see there called the antrum, starts to appear. And at the same time, the tissue around it begins to organize itself into some very important specialized layers. And believe me, these layers are super specialized. You get an inner layer, the theca interna, that acts like a tiny hormone factory. And then outside of that, you have the theca externa, a tough, fibrous layer that's all about structural support. And those granulosa cells lining the antrum, they do something absolutely critical. They convert androgens into the estrogen that really drives the whole cycle forward. So after about 15 days of this really intense growth, one follicle starts to pull ahead of the pack, becoming what we call a mature or Graafian follicle. I mean, just look at the size of this thing. That antrum is huge now, and the oocyte is kind of perched on this little stalk of cells, totally ready for the main event. It gets so big that it literally starts to bulge right out from the surface of the ovary. All right, so let's do a super quick recap of who does what. The cortex is where the oocyte is made. The medulla is the support system, and then you've got the theca and granulosa cells teaming up to handle the all-important job of making hormones. So, our follicle has won, it's made it through the developmental race, it's matured, and now it's sitting right there on the edge of the ovary. All it needs is one last powerful signal to push it over the finish line. And that signal, it's a huge surge of something called luteinizing hormone, or LH, that comes from the pituitary gland. This massive hormonal spike is the trigger. It actually causes the wall of the follicle to break down, and boom, the oocyte is released from the ovary, ready to be swept into the uterine tube. Okay, so the oocyte is on its way. But believe it or not, our story isn't quite done. What about the structure that got left behind in the ovary? Well, that ruptured follicle is now facing a fork in the road, with two totally different futures ahead of it. So what happens next all comes down to one simple question. Was there fertilization? If pregnancy occurs, the leftovers transform into the corpus luteum, a vital, temporary hormone factory that just starts pumping out progesterone to support that potential pregnancy. But if there's no fertilization, it just degenerates into the corpus albicans, which is basically a small, inactive scar. And this is what I find so fascinating. These little scars, these corpora albicantia, they never actually disappear completely. It means that the ovary literally holds a microscopic, physical record of every past cycle. It's a history written in faded scar tissue. So, what do we take away from all this? From this whole microscopic marathon? Well, from a starting lineup of 1 million contenders, an incredible process of selection, growth, and perfect timing allows just one to get its chance. It's a really powerful reminder of the immense potential and the fierce competition that underpins the very, very beginning of life.